Hello, I'm STS-130 Mission Specialist Nicholas Patrick, and you're watching NASA TV.
Good morning, Endeavour, and a special good morning to you today, Nick.
Good morning, Shannon, and good morning to all the students at Harrow School in London and to all the students everywhere from 200 miles above the Atlantic. I'd like to encourage you all to follow your dreams. Good morning.
And thanks a lot, Nick.
The song 40 Years On, which is the school song of the Harrow School. The wake-up music today was for Harrow alumnus Mission Specialist Nick Patrick.
This is Mission Control Houston with a view on the outside of the International Space Station, looking at the new Tranquility node and the cupola, which is currently still attached to the end of Tranquility but will be relocated during the cruise day today. That work will start with the depressurization of the cupola by Endeavour's astronauts Terry Virts and Kay Heyer. And then Heyer and Virts will begin operating Canadarm2, the station's robotic arm you see poised and standing by there. They will use that to latch onto cupola and then eventually relocate it. View inside Tranquility, watching Terry Virts and Kay Heyer work through the procedure to depressurize cupola, which is on the other side of the hatch seen here. This is a view inside the station's Destiny laboratory. Astronaut Kay Heyer is positioned at the robotics workstation, which she and astronaut Terry Virts use to operate Canadarm2. There's time to get set up for that operation of the arm to relocate cupola while the depressurization is in work. This is now a live view inside the station's Quest airlock, where the spacewalkers for this mission, Bob Behnken and Nicholas Patrick, are working on configuring tools for the mission's third spacewalk. There are 2 days in between the second and third spacewalk now, so the third excursion is scheduled on flight day 10. We see Behnken and Patrick inside the airlock, getting their tools set up for the mission's third spacewalk. They're doing most of this work today, as the next day's work for them will focus on using the space station robotic arm to relocate the pressurized mating adapter number 3. They are the crew members that will be operating Canadarm2 for that relocation. This is a video camera that was set up by Station Commander Jeff Williams in a small window in the hatch of the Tranquility node on the port that is facing Earth. That is the port that the cupola will be relocated to today.
For Jeff and CBCS, we have a good camera view.
The depressurization of the cupola has taken a little longer than expected, and there is some residual air left inside that will be vented overboard later in the procedure. But the Environmental Control and Life Support System officer here in the International Space Station Flight Control Room was comfortable and wanted to continue on with the procedure to perform the leak check to ensure that there's a tight seal there between the cupola and Tranquility. So that is the next part of the procedure that Virts will be going through.
Closing and not anything else.
Houston from Station for Robotics. We're beginning motion on the arm.
Houston copies on the big loop.
This is Mission Control Houston. The station's robotic arm, Canadarm2, is now being maneuvered to latch onto the cupola. This is Mission Control Houston. The space station robotic arm is paused in this procedure to latch onto the cupola module. It is being operated by astronauts Terry Virts and Kay Heyer. Inside the space station, Commander Jeff Williams is completing the final closeout steps in the procedure that depressurize the cupola, preparing it for its relocation.
In Houston, the cupola depress is complete. The valve, of course, is closed and capped, and the vag is left completely intact, connected up to the PCA for the next operation.
Roger.
Endeavour ISS, this is Houston ACR. Please stand by for the NASA Explorer School questions.
Hi, my name is Aaron Lee from Stewart Middle Magnet in Tampa, Florida. Our teachers took us on a camp out near the Kennedy Space Center so we could get up at 4 a.m. to see your shuttle launch, and it was awesome. But my question is, why did you have to launch so early?
Well, first of all, we'd like to apologize for making everyone get up so early. We were up pretty early ourselves. The time of a launch is determined by the orbit of the International Space Station. We need to be able to launch from Florida and to catch up to the International Space Station to rendezvous and dock. And we want to do that with the minimal amount of fuel that we expend, because remember, everything that we lift off of the pad, it cost us basically our amount that we can take to orbit. So we don't want to have to take any extra fuel that we don't really need to orbit. So we have to stay to these very tight little short launch windows to be able to catch up to the International Space Station. So again, sorry for the time, but hope you enjoyed the light show.
Hi, I'm Daniel Lorenzo from Stewart Middle Magnet School in Tampa, Florida. And my question to you is, how long do you guys have to train before going into outer space?
Well, that's a great question. You could generally answer that question all your life, because every experience that we have, every bit of knowledge that we have sure comes into play when we're here in space, because you never know what's going to happen next. But generally, for a space shuttle mission, we train for a minimum of a year specifically for the task that we're going to do on board that mission. Prior to that, though, we all train generically as astronauts for 1 to 2 to multiple years before we get assigned to a flight. So for a space shuttle mission, the training is a minimum of a couple of years overall. For a space station mission where the crew members are staying for longer duration, they can train many years, because they train not only in the United States but also with our international partners. So it's multiple years of training, but of course prior to that, lots of years of schooling and experience that all comes into play.
My name is Summer Heckman, and I go to Vernon School in Portland, Oregon. And my question is, do you have issues with keeping things clean on the space station? And if so, is it possible for mold to grow in space or on the space station?
That is a really, really good question, because it is a big issue. The space station and the space shuttle both have very good air circulation systems with fans and filters to keep stuff clean, but everything floats. There's no gravity. So on Earth, it's really nice. You can see there things float. If you have dust or lint or just anything like that, it tends to stick or it tends to fall to the ground, and you can sweep it up. In space, it doesn't. It floats around, and you see little specks of things floating by occasionally. And when you drink in your water straw, unless you get all of the water out of your straw, when it comes out of your mouth, it might flick a couple little specks of water, and over time those can grow mold. So we spend a lot of time on the shuttle keeping things clean, and the space station crew spends a lot of time, probably once a week, just keeping things clean, because we have seen mold grow in the past. And in fact, right around the corner down there, you can see there's some plants growing. So things can grow in space, and that's why it's really important for us to keep it clean.
Hi, my name is Maya, and I would like to know how long does it take to prepare the space shuttle before it launches?
Well, as you know, the space shuttle is a very complicated spacecraft, so it does take a while, and it takes a lot of people, quite a great team of people that prepare the space shuttle for launch. And you know, space shuttle is made up of several components. There's a space shuttle orbiter. There are the solid rocket boosters. Those are the two white rockets that strap to the sides, and then there's a big orange external tank that holds our fuel. So to get all of those components together, it takes quite a bit of time. The absolute minimum amount of time from the time that a space shuttle orbiter lands until the time that it can launch again is about 2 months, but that's very, very aggressive schedule. It takes longer actually to prepare the tank and the solid rocket boosters. Those would have to be waiting for it. So after landing, the team in Florida processes the orbiter in a horizontal position, like working on an aircraft in a hangar, and then they rotate it into the vertical position and attach it to that solid rocket boosters and the external tank, and take all of that together out to the launch pad and get it ready to launch again. So it actually takes quite a bit of time, but it can vary depending on what our schedule is.
Hi, I'm Hannah from Stewart Meadow Magnet School in Tampa, Florida. I have a question. What was the most difficult obstacle that you had to overcome to become an astronaut? Thanks.
Well, I don't know that I'd really call it obstacles, but it is very important to have a good, strong math and science background to be even considered to be an astronaut, but also just overall technical experience, and it really helps to have some flying experience as well. So I don't know that, again, that I would really call it an obstacle, but there are so many very qualified folks, very, very smart, very educated, and with a lot of experience, that NASA has a tough time selecting the astronauts from so many qualified candidates. So maybe I just feel that I was very fortunate to be considered for selection as an astronaut, and also that I was selected. So I would suggest that you just keep studying hard and find the things that you love to do and gain your own expertise there, and apply to be an astronaut, and hopefully someday you'll be able to fly in space as well, as you saw two fellow astronauts floating right by.
Hi, Bob.
Hi, my name is Taylor Church, and I go to Edward Harris Junior Middle School in Elk Grove, California. Have you ever personally tried growing plants in space? If so, how did the experiment turn out? And if not, have you ever been on board a mission where a plant experiment has taken place? Thank you.
Yeah, that is a great question. Actually, in the next module down for me, we're in Node 2. So in the lab, the U.S. lab, there are several big bags where plants are growing right now. It's one of their experiments. And in fact, the space station is a very big laboratory. There's a Japanese lab, a U.S. lab, and a European lab. And plus the Russians have their own experiments going in their segment. So there's a lot of different experiments happening here. On our space shuttle, our main job was to bring up Node 3 and Tranquility, but we have some experiments also. We have some basically vaccination testing, and there are some viruses down there that we're doing some testing and experiments on, but there's lots of experiments going on here. And as you can see, this is we're in like the central hub here, so there's a lot of traffic going on. And so pardon our crewmates as they translate by with important hardware.
Hi, my name is Pravina Ramlal, and I go to Stewart Middle Magnet, and I live in Tampa, Florida. My question is, why will NASA scrub a launch if the sky is cloudy or rainy?
Again, a very appropriate question for us, because our first launch attempt was scrubbed because of clouds, and there's a couple of problems with clouds and rain. First of all is our rocket itself. You don't want to damage the space shuttle, so if you fly through certain types of clouds with lightning or rain, you could get a lightning strike, which actually happened on one of our Apollo missions. And if you fly through rain, the rain could damage the vehicle because we accelerate really fast. We're going about 100 miles an hour by the time we clear the launch tower, and in less than a minute, we're going supersonic straight up. So the rocket goes very fast through the air, and so that could be dangerous. The other thing is we want ground cameras to be able to see the shuttle, or whatever rocket it is. When we're launching unmanned rockets, it's the same thing. They need some visibility to be able to see it, to make sure that the trajectory is going in the right direction.
Hi, my name is Sabrina, and I want to know what kind of tools you use to fix the space shuttle.
Well, hello, Sabrina. Thank you for that question. That is a really good one. We have a toolkit in the space shuttle, and we have several toolkits here on the space station. And one of the biggest things that we've been doing here during our mission, and Kay is just showing me this bag. If you hear it, it sounds like wind chimes. But there's a wrench and some pliers and some different types of screwdrivers and ratchets and scissors. There's all kinds of stuff here, sockets. And so if you're a tool person, this job is really fun, because for the last several days and for the next few days, we are in there turning wrenches and screwdrivers and all kinds of stuff to attach Node 3, our new module, and then later today to move the cupola and to attach that. So we have lots of tools, and we use them a lot.
This is Mission Control Houston with a view inside the space station's Destiny laboratory module. Astronauts Kay Heyer and Terry Virts are back at the robotics workstation, standing by to maneuver Canadarm2 to move the cupola element from its current location on the end of Tranquility to a port on the Earth-facing side of Tranquility. Next to them is Station Commander Jeff Williams, who's been working at the computers to operate the common berthing mechanism and the latches and bolts that are holding cupola in place. During that procedure, one bolt jammed, and during the initial planned troubleshooting step, another bolt jammed. So one continues to be jammed at this point, but not the same as the original one. The next option that the mission control team has is
block 13 now.
the next step is to de-rigidize or command the joints in the space station robotic arm to go to limp.
Okay, we'll send the stop command.
For about 30 seconds as the arm is holding the cupola in place now.
And Houston, this time we got bolt 1-3 jammed.
And Houston sees that, Jeff.
I'm sure you guys are talking about possible loads from the internal structure contact.
Jeff, right now we're talking about upping the torques on the bolts, and we'll get back to you after we've had some more time to work through it.
Yeah.
The crew on board the International Space Station will now try the procedure again to deploy the 4 latches that are holding the cupola in place on Tranquility. Commander Jeff Williams and Mission Specialist Kay Heyer had worked through a malfunction procedure after getting an abort message from trying to deploy the 4 latches on the common berthing mechanism, basically resetting the software and attempting the deployment again. The reset of the software was successful, and the redeployment attempt will come shortly. This all in part of the procedure to unlatch the cupola from the Tranquility node.
And Houston, good news, we're complete.
Houston concurs.
Station Commander Jeff Williams confirms that the latch is deployed as planned.
We're go for cupola deburst.
Houston copies, and in step or procedure 1.410 SSRMS cupola relocate. Step 5 is complete. You can pick up in step 6.
Houston from station for robotics. We have the arm in motion, going in motion.
Houston copies on the big loop.
This is Mission Control Houston. The team in the International Space Station Flight Control Room is monitoring the progress of relocating the cupola using the station's robotic arm, Canadarm2. Astronaut Terry Virts and astronaut Kay Heyer are at the robotics workstation to conduct that maneuver. Virts indicated that the seal on the common berthing mechanism for cupola looks clear, but that an electrical connector has popped out from behind the center and that it is recessed and cleared the mating surface, so the team agreed to continue on to the next position of cupola at the pre-install position just nearby the attaching port.
Go ahead, Jeff, Space Ground 1.
Yeah, that wire that we're looking at, I clearly remember in the cupola. It's in its nominal location. When I reinstalled the thermal MLI, the Velcro appeared to be intended to be installed such that that wire is visible, and that's just the way I remember leaving it.
All right, thanks for that info.
Big loop, we copy. I'll go ahead if you want me to do another survey or just zoom in on the electrical cable.
Let's just focus on the cable, Kay.
And more.
This is Mission Control Houston with a zoomed-in video camera view of a connector inside around the thermal insulation on the port of the cupola that will be attached to Tranquility again. Engineers just wanted to take a close-up look with the video to make sure that that won't interfere with latches to connect cupola in place.
Looks good. We'd like you to proceed to pre-install. Once it pre-installed, take a look out the window and make sure that this wire hasn't moved and it's going to be out of the way for the latches.
Got 4 RTLs that are steady. We're going to continue in the procedure.
Houston, concur.
At 12:25 a.m. Central Time, the crew has indicated that there are 4 ready-to-latch indications. That means that cupola has made contact with the port that it will be attached to. The next stage will be to deploy 4 latches to temporarily place a cupola on Tranquility, and then a series of bolts will be engaged in a 2-stage fashion, so that in the end there will be 16 bolts securing cupola to its position on Tranquility.
On space on the big loop, the SSRMS is limped, and we're going for second stage capture.
Getting a good shot now of the cupola there on the left portion of your screen, now in its permanent location on the nadir port of the Tranquility module. Nadir means that it faces down toward Earth. You can see it's still covered up. Those covers will come off during the third and final spacewalk of this mission that's going to be conducted by Bob Behnken and Nick Patrick.
Both restraint systems moved.
As you can see, the end of the station's robotic arm has successfully let go of the cupola. And Nick Patrick and Bob Behnken, who are currently working inside the Destiny laboratory at one of the robotics workstations there, will continue to back away this arm and drive it over toward pressurized mating adapter number 3. It is, as we mentioned, currently on top of the Harmony node, which in this view would be toward the bottom. It's over toward where the shuttle is currently located. The shuttle docks with pressurized mating adapter number 2, but PMA 3 has been located over on Harmony temporarily to basically just get it out of the way of all the different robotics work that had to be done during this mission, getting Tranquility installed as well as the cupola moved over. But if you look toward the left part of your screen, you see an empty hatchway there on the end of Tranquility. This is where that PMA 3 will ultimately be installed. That is where the cupola used to be prior to today's activities. The station's massive robotic arm being moved from left to right as it turns its attention away from the cupola over toward pressurized mating adapter number 3. You can barely see the tip of PMA 3 on the very bottom right-hand portion of your screen. It is actually on the top of the Harmony node. It's a little bit misleading because this camera angle is turned upside down. But that robotic arm is going to be used to grab onto PMA 3 and to begin the process of removing it and move it over toward Tranquility. The majority of that activity will take place tomorrow during the cruise day.
Endeavour ISS, this is WOR. Do you read me? Copy?
WR, we have you loud and clear. How us?
Yes, indeed. Who am I speaking with?
You've got Bob Behnken, one of the mission specialists, and Terry Virts, our pilot on Endeavour.
All right, Bob, good morning to the both of you. We don't have a lot of time here, so let me get right to it. This node, Tranquility, that you folks have brought up to the International Space Station, I understand as of yesterday it had some troubles. You were part of the spacewalk on installation. Where does it stand today?
Well, we're marching right along at this point. We had a little bit of trouble with what's called the center disc cover. It's a piece of material that needs to be put in place prior to some relocation activities, and there was some interference with that. But from a spacewalk perspective, that was no impact, and we were able to go outside and hook up the cooling system after having hooked up the electrical power on the previous spacewalk. So Node 3 is up and running. There's fans and cooling and lights even, so it's looking good.
Robert, this is not your first time up, and this is certainly not your first spacewalk. Can you describe, I mean, is it hard moving all of those big pieces and being in that, what appears to be bulky spacesuit of yours, or is it similar to doing any sort of manual labor job?
Well, we kind of describe some of the work that we do as kind of a little bit of heavy lifting. When we were outside in that suit, it's actually kind of like being inside of a balloon. It's pressurized at about a little over 4 pounds per square inch, which means every time you close your hand on something, you have to change the shape of that balloon. And doing that for about 6 hours can kind of wear you out. With all the gear and all the tools together, we weigh, if we were on the ground, close to 600 pounds inside of that suit. And so it does take some training and some careful practice in order to make sure that you don't get that 600 pounds moving very quickly. Otherwise, you got to put a lot of force in with those hands that are squeezing inside of those balloons to slow it down. So it is a pretty good workout, and we all spend quite a bit of time in the gym trying to get in shape before we step up here to do spacewalks. On this flight, we'll do 3 spacewalks with just 2 spacewalkers, and so each of us will go out for 3 different occasions, and for a total of about 18 hours. And that can be really exhausting if you haven't trained for it appropriately.
We're talking live this morning with Space Shuttle Endeavour. Its pilot is Terry Virts. Terry, I understand this is your first trip into space. So far, so good. What was the reaction? What was it like, and did it meet expectations?
It's been a lot better than expectations. During our launch, it's about 8 minutes with the engines running before we get into space. We go from 0 to about 17,500 miles an hour in about 8 minutes. And I had a chance to look outside on the way up, and I was able to see the moon outside on the horizon. And then as the shuttle did a roll maneuver, I caught a quick glimpse of the entire east coast of the United States, and it was just an amazing sight. And then you're under this G-force, 3 Gs. It feels like 3 times your body weight. It's kind of sitting on your chest, and then boom, the engine shut down and you're floating. And then a few minutes later, we were going over the Alps, and I was really amazed. The view of the Earth was different than what I expected, much better.
All right, now I understand, or I heard that on takeoff, some of the insulation might have separated. Is that true? And if so, are you concerned?
We're not concerned at all. We did a lot of inspection on the second flight day that we were in space, and we looked at every nook and cranny of the bottom of the heat shield of the space shuttle, and we have a very large team of engineers on the ground that looked at it. There were a couple of small areas where a tile came loose, and on the top of the wing there was a piece of material that's sticking up a little bit, but overall it looks really, really clean, and we don't have any concerns at all up here. We've mainly been just really busy working from all day long getting these 2 modules that we've been installing. That's been our main focus.
Terry, there are only 4 more flights of the shuttle program here in the United States, and after that we really don't have any other way to get back and forth to the space station or even into space except with the help of the Russians and their equipment. You're a fairly new astronaut. From your perspective, how disappointing is that?
Well, it'll be sad to see the shuttle retire, that's for sure. A lot of people have spent a lot of years on it, but it's been 30 years, and every program eventually comes to an end, so hopefully we'll move on to something bigger and better. And you're right, the Americans will not be able to send astronauts into space. We will be using the Russian Soyuz. In fact, I had a chance today several times. There are 2 Soyuzes docked to the space station right now, so I've been down there and taken a look at them. But you're right that America will not have a way to launch astronauts.
The Soyuz space capsules are almost as old as the space shuttle, are they not?
Actually, the Soyuz space vehicles are quite a bit older. At least the original Soyuz are. They've been around since the Soyuz and Salyut days many years ago, and so the Soyuz has a much longer history than even the shuttle does. But the Soyuz has been upgraded over the last several years. There's been a couple of variants, and they continue to make improvements. And what's different between the Soyuz and the space shuttle is that the space shuttle is reusable. We land it, and then we refurbish it, and then fly it again. But each Soyuz is replaced pretty much in its entirety before it goes out to the launch pad to launch again. And so it's almost like getting a new vehicle every time with the Soyuz.
Endeavour ISS, this is KTVI-TV. How do you hear me?
KTVI-TV, we have you loud and clear on board the International Space Station.
That is fantastic. Good morning from St. Louis to both of you. How's it going so far?
Well, good morning to you guys from us here on the International Space Station. So far, it's going really well. We've got the Node 3 attached to the space station. We've got the cooling and electric hooked up to the outside of it. And today, our pilots relocated the cupola, the nice window that's going to be the window on the Earth from the International Space Station to its new home on the underside of Node 3. So it's going really well.
Well, Bob, you know, we saw your shout out to St. Louis last week. Tell us more about your upbringing here. Obviously, we are so proud to have you on board there.
Well, I actually grew up in St. Anne, which is over by the airport there, Lambert. My father's a construction worker, and my mother had worked at McDonnell Douglas when I was a child, and so I grew up right there in St. Anne. Went to St. Anne Elementary, which is since closed, and I think they've built a new school there at this time. And I went through the Pattonville School District and graduated from Pattonville High School.
I am curious, Terry, what does it look like from space? I mean, like, we've had a lot of snow, so can you see the snow from space on Earth?
Oh, yeah, we can absolutely see the snow. The thing that's really stuck out to me is just how snowy Earth is right now. I think we're having a cold winter because it seems like everywhere we go, except for Central Africa and the desert, you see snow. especially over Russia and Siberia, Mongolia, there's an entire continent that's nothing but snow. So it does look like it's been pretty cold down there. But the view of Earth is really spectacular. This is my first flight, and it was different than what I thought. There's a lot more color to it, and it's even better than what I thought I'd been. As much as I've heard, as many pictures as I've seen, there's nothing like seeing it in person.
That is amazing. I want to ask Bob another question. We understand you brought some special items along with you from WashU, Bob?
I do have a couple of items from Washington University. I have a pendant that was from the mechanical engineering department that they provided for me that is on board Endeavour. And I also have a certificate from the physics department as well that I'm flying for them. So those are two departments right there in St. Louis that I graduated from before picking up my education out on the West Coast and then going into the Air Force.
Station, this is WREG Memphis. How do you read?
We've got you loud and clear.
All right, thank you very much. I'd like to start with Colonel Wirtz. This trip a long time coming for you, and it looks like the main part of this mission is going to be taking that Tranquility module out of the shuttle bay and attaching it to the International Space Station. How did that go over the weekend?
That's right. We've had a really great mission. It's the first time that the space shuttle or that anybody has brought up two modules at once. We have what's called Node 3 or Tranquility. It's a large living facility, and then we also have a module called the Cupola that was launched attached to Tranquility. And so several days ago, we took those out of the payload bay while Bob and Nick Patrick went outside and disconnected it. I moved it from the shuttle and attached it to the station. And then just today, we detached the cupola from one end of Tranquility and moved it around and reattached it to the bottom. And we've been busy all day connecting bolts and hoses and that kind of thing, getting these modules ready to go. So we've had a really successful mission so far. Bob's done 2 spacewalks, and we've got both of our main modules attached to the station, which is really, really good news.
Now, Mission Specialist Bankin is from Missouri, just a bit up the road from us here in Memphis, is back on Endeavour with a couple of spacewalks under his belt already. Has everything gone perfectly according to plan, or have you had to adjust a little bit on this particular mission?
Well, I think that the folks that are on the inside have had quite a bit of adjustment, trying to just deal with some minor issues that have come up with interference of a lot of hardware. There's a lot of parts that need to be moved around in order to accomplish moving a module out of the shuttle payload bay and actually getting it attached to the International Space Station. And then certainly once you get that module attached and you start to try to take it apart and move pieces of it around the space station, you can imagine keeping track of all those pieces and making sure they all fit just right takes a lot of effort and a lot of folks working together to make it happen. Certainly during the spacewalks, things have gone really closely to our plans. We've been able to get through all of our tasks on the last couple of spacewalks, which was really nice. We're able to get electricity and cooling hooked up to the outside of those new modules, which is also really exciting. It means that the folks who are working on the inside aren't wearing headlamps and doing cave diving in order to get their work accomplished. So we're really happy about that as well.
Maybe you could tell us a little bit more about what the Tranquility module is going to do for the scientists that will be aboard the International Space Station. It really adds a little bit more room to the space station, doesn't it?
Oh, it adds a lot. It's a very large module. It's one of the largest on board, and it's going to be mainly a living area. It has several different life support racks that help to recycle oxygen and water and that kind of thing. There's a large exercise machine on there that helps a lot. When you live in weightlessness for 6 months, it can really take a toll on your bodies, on your bones and your muscles, and being able to do exercise is really critical to being able to live in space. And it also is going to have the cupola attached to it, which is going to have the ability to put a robotic control station so you can look outside and move the robotic arm.
Now, you were mentioning a little bit
Probably
about
the most important thing that it will do, partly the most important thing that it'll do for scientists is it will get the bathroom compartment out of the U.S. laboratory and get it over into another module to kind of allow more science to happen in that laboratory and turn it into less of a hygiene facility.
Now, you were mentioning the exercise in outer space. Does this mean that cold bear machine that we've heard so much about, that exercise machine, is that going into the Tranquility module?
It sure is. That's one of the, yeah, I'm staring at it right now. It's just a few feet from me, and that's going to move down there every day. The station crew members, they run on the treadmill. They have a cycle type machine, and then they have this weightlifting machine, something called ARED, and exercise is an important part of their day. They spend a couple hours every day exercising, and the great thing about it, having had humans, Americans, and our international partners on board the space station since 2000 continuously. We're going on 10 years now. We've shown that we can live and work in space for long durations, and guys come back in great shape, and that's due to a large part because of the exercise that we do.
I wish we could spend more time chatting with you, but we are out of time. Pilot Terry Virts and Mission Specialist Robert Benkin, we thank you for joining us this morning on Daybreak. You get an extra day in space, I understand. Enjoy, safe travels, and we'll see you back down on the ground within about a week. I think that's next Sunday that you're coming back now.
Have a good day, Memphis. Thanks for talking with us.
This is heading from the Shuttle Endeavour over towards the International Space Station. And here entering Node 2 of the International Space Station. There goes Nick Patrick. Here's the commander of the International Space Station, Jeff Williams. Moving from Node 2 to the lab. As we progress from forward to aft in the lab, we pass the robotic workstation and enter into node number 1. We can now take a right turn and enter the new node 3. This is a view inside node 3, looking towards the port or left side of the International Space Station. This is the hatch. And we get all the way to the end and turn all the way around, looking now towards the starboard. You can see all the way across towards node 1, the equipment lock and the airlock. This is our nadir hatch, and earlier today we were able to just look out that window and see down on a beautiful Earth. If we looked out there now, we'd actually see a cupola because we replaced the cupola there to the nadir or Earth-facing location. These are just more views of inside node number 3. And here we see a little bit of the work we were doing inside node 3. That sound you hear is the venting of the cupola before we relocated it. Cupola is just on the other side of that hatch, and Terry opened up some valves to be able to vent the atmosphere that was inside the cupola to the vacuum of space. That allowed us to remove the cupola from the port side and move it around to the bottom or nadir side of node 3. As a safety precaution, we do wear earplugs when we're venting like this because you can hear the kind of high-pitched noise as the air is escaping. Once again, this is showing the nadir or bottom-facing hatch before the cupola was placed there. This is just giving you a glimpse of what our view might look like. This is just one single window, but now that we have the cupola there, we're going to have 7 windows facing down in this direction. Terry and I are working in the node 3. Now back to the lab. Terry's setting up the robotic workstation in order to relocate the cupola. He's going to use the robotic arm to reach out and grab the cupola and to move it around to the bottom.
There's the cupola looking out the window. Here's Bob and Nick in the airlock. They've been practicing resizing EMUs, so they're going to be the world's experts on resizing EMUs. I think Bob said they're going to do 4 resizes, and they only brought up 3 EMUs. So that's been good. I know the guys on the ground have been working really hard to come up with these plans. I know that's a lot of work. Okay, here's the Russian segment. I think one of our cosmonauts filmed this for us, or it might have been Stevie Ray. He's flying through the FGB, which is a storage area just aft of Node 1. And when you come into this area, you can go down to the docking compartment, or you can go up to what's called the MRM. And then here is the view. I think Steve's right here, so I'll let him tell you what he's filming.
Well, this is pretty constricted window environment here, and the camera was almost too big to see through the window, but if you look just in the bottom part, okay, there's Endeavour, the port wing of Endeavour, and if you look just in the bottom middle of the screen, it's the cupola on its way to its new home with Kay and Terry handling the robot arm.